This is the second video just re-explaining why integration gives us the area underneath a graph. This time we're not going to do it using antiderivatives, we're going to use it using integration directly, which also helps explain some of the notation. So what we're going to do is we're going to approximate the area underneath this graph as a series of rectangles again. Okay, like that, and you can imagine we could continue this process all the way along, more and more rectangles. Okay, so if we want to approximate this area, we would say that it is the sum, sigma written like this, just means the sum of, and we would do the height, again y, times the width, a very small x, and if we add all of those up, that's what sigma means, it means the sum of these. If we add all of these up from when we start at 1 up to n, the number of rectangles we have, we take our y values, so we take y1, y2, y3, y4, and so on, until we've done all n of our rectangles. Then we will get an approximation to this area. Again, how do we get a perfect approximation? We let delta x go to 0. Alternatively, because we'll be going up to some definite value, so we'll have n rectangles, if we let the number of rectangles in that area tend towards infinity, if we get as many rectangles as possible in there, delta x must necessarily reduce, so two things which will essentially tell us exactly the same. Then this sum will again become a perfect approximation. We'll now have an infinite number of rectangles. And each one of them will be infinitely narrow. So we'll have a perfect approximation. Because this is hard to do, again we're looking at when this delta x goes to 0. For that perfect approximation, we use this sign. Now we can explain that this integral sign is actually an elongated S. Okay? Reminds us that it's telling us the sum of many things. So the integral of y with respect to x will give us this area. One little footnote, we do need to say what x values we were going between. So if we call that a and this upper limit b, we put what we call a limits on the integration. So our lower limit always goes down here. We started at a and we go up to a value b. Okay, so we think of integration as an infinite sum of many things which converges to the integral. Okay, next video we'll look at how we find areas in practice.